here we want to graph. We've been doing this. Again, we just want to focus on cosecant and the process that we use. So again, I want to emphasize the only part we're taking a reciprocal of is the actual cosecant and the 4x portion. If we kind of identify all these pieces, our amplitude is absolute value of -1/2, which implies that the amplitude is 1/2. We also want to note that we're reflected. And we do want to carry that part over into the sine function when we graph it, right? We're going to take the 1/2 and the negative both with us, but the 1/2 is not part of the reciprocal. And that's a really, really important distinction for us to make here. We also have the period of this function. So we're dealing with cosecant, reciprocal of sine. So we're looking at 2 pi as our original divided by b, which is 4, which gives us period is pi over 2. Okay, so that's quicker. And then we also have a vertical shift up 2. Now it's really important, again, you can distinguish between a vertical shift and horizontal shift. If this was horizontal, we would have parentheses around it. Because those parentheses are missing, and I sure hope they erase when I do that. The computer is slow tonight. Okay, so to put this together, what we want to write out is what exactly does this look like in terms of sine? So if we were to graph the reciprocal, the sine function, you would have -1/2 is still there, 1 over sine 4x plus 2, okay? Again, the 2 and the 1/2 and the negative, well, negative is really not as, it's not going to affect it as much, but those things do not follow it to the denominator, okay? So I'm going to bring out the key points for sine. And we're going to graph sine so that we can graph cosecant. Okay, so our normal starting place is at 0, 0, and that is not going to change with the period. At least the x part is not going to change with the period. It's still going to start. It'll only change if there is a horizontal shift, right? So we're still starting at 0. Okay, so we want to look at these points. I do have to point out not all of these numbers are going to be the same because the period's different. We're only going to cross a distance of pi over 2, not a full 2 pi. So what happens, and we need to make sure we remember it's reflected. So what happens at x is equal to 0, right? Well, we're looking at 4 times 0 is still just sine of 0, right? That part doesn't change at all. So input is the same, but what we are looking at is -1/2 times 0 plus 2. And that gives us the point 0, 2, okay? Before I can go to the next number, I need to figure out what that gap value is, right? So that gap, and that takes pi over 2 and it cuts it in fourths. So it's pi over 8, and really that's just how we know how to get from one number to the next number to the next number, right? So here, 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 and here. So plus pi over 8. And so this gives us, well, 0 plus pi over 8. Just going to be pi over 8. I'll circle back around to that. And then we've got a -1/2 times 1 plus 2. Okay, so this is pi over 8 and -1/2 plus 2, so 1.5. You can also get away with, 1.5, 3 over 2, whatever makes the most sense to you. We're going to have pi over 8 plus another pi over 8, one from this previous step, one from the gap over here. We're going to have negative 1/2 times 0 plus 2. So if we have pi over 8 plus itself, that's 2 pi over 8, or pi over 4 is better, right? So pi fourths, and that's going to be 2. And that kind of follows the pattern of signs, so that makes sense, right? We're going to add another pi over 8, so I'm actually going to revert back to the common denominator format. So 2 pi over 8, equivalent to pi over 4, plus pi over 8, that's the gap, and I'm saying negative 1, I'm saying negative 1/2, times negative 1 plus 2. So that's 3 pi over 8, and then positive 1/2, so 2.5, again, adjust to decimals or improper fractions, whatever you're comfortable with. Last but not least, 3 pi over 8 plus another pi over 8, negative 1/2 times 0 plus 2. So that gives you 3 pi over 8 plus another pi over 8 is 4 pi over 8, which is actually pi over 2. And that's good for us because, again, it agrees with the period, right? A lot of checks and balances built into this. I know I mentioned that before. So pi over 2, this is 0 plus 2, so just 2. And again, it agrees with what we know about sines graph, and that's always good news. So how does this behave? Well, because we've reflected it does throw off the maximum and the minimum portion. So this is actually a minimum, and this is actually a max. So if the labels get to be, just a lot because we're flipping them around all the time, it is just important to realize it is reflected. Make sure that happens. This x-intercept is going to end up being a vertical asymptote at that x value. So x is 0. You're going to have another one here. At x is pi over 4 equals, and another here at x is pi over 2. Then what we need to figure out is what happens to each of these. Well, if it's a minimum, because it's been reflected, right, for sine, that means this is a local maximum. It's going to be one of the upside down portions, not technically a parabola, but it sure looks like one. For cosecant, right? And then similarly, if this is a maximum for sine, we're looking at a local minimum for cosecant. Okay, so let's sketch out a graph. I'm not going to go to the negative side very much. It's just a convenience thing. I'm just not going to. So if we were to sketch this out, let's draw, we have some vertical asymptotes here. Also vertical asymptote. And then I'm going to just mark off pi over 8, pi over 4, 3 pi over 8, and pi over 2. And we can continue on, right? 1, 2, 3, 4 values past that. Again, I kind of said before, you can label them. It is fractions at that point. You know the spacing between them. So if you need them, I do trust that you can find them. We also have a vertical asymptote right in the middle, right here. Right? And one at the end. And I'm going to worry about the second cycle in just a minute, not just yet. So each of these are x-intercepts, but that's kind of their original location. We've actually shifted everything up 2 units. So call that 2, call that 3, and that would make this 2.5 and 1.5, which we are using for this graph. So technically, without adding too many different colors here so we can actually read this graph, technically all of the sine graph has been raised up to this new kind of false x-axis. I think I did this in the past. So everything's been raised. So when I say x-intercept, I'm saying it crosses that 2 line. So just be careful. it gets reflected. So we actually go down here, back up, and then up here and back down. So if we were to sketch that in something like this, and then I can bring out my cosecant function, again, remembering that this is now a vertical asymptote, and then these points right here. Oh, that was a little weird. Let me fix that. Caved in, kind of weird. I crossed it oddly there. Okay, and then this will cut into my words a bit, but look like this. Now, if we need to extend this, which we do, you just keep that same pattern, right? So vertical asymptote, vertical asymptote. And then we continue. So we're going to go down, back here, up, and back here. And you can see sine kind of carrying on as we do that. And then you just mimic the same pattern. So down here and running into my answers, but up there. Okay, so that's it for this one. Those are supposed to be pink. I guess they're not changing.